Welcome to the presentation on internal versus external iterators. My name is Venkat Subramaniam. We're going to talk about iteration in this presentation. First of all, let's talk about what's iteration. Well, when we have a collection of objects, we want to navigate through each of the elements and do some operations with the elements. Well, trivially, it may be as simple as printing each of the values, but something more complex could be done with iteration as well. Let's talk about iteration in mainstream languages, how we have done it for a long time, and then we'll see how this is beginning to transform and change as more and more languages are adopting a functional style of programming. There's a benefit to doing iteration a little differently than we have used to, so that's what I want to focus on in this presentation. So iteration is where we're going to navigate through each of the elements in a collection and process it, do some operation. But let's start with the good old iteration as we have done in traditional languages so far. So let's start with Java for a minute. Let's say for a second we have a collection of values, let's say integer values to begin with. So I have a collection of integer values called numbers, for example, and then let's say we have an arrays of these numbers. So we'll say dot as list, and let's take a few examples of these numbers, the first 6 numbers in the integer starting at 1. Now, how do I go about iterating and printing these values? The age-old way of doing this would be to start with int I equal to 0, I less than numbers dot, is it size or length? Well, I guess it's size. And then we would say I plus plus. Now we have to break and take a look at this and say, is this less than or equal to? How many of us have run into these off by 1 errors? It's a lot of fun when we have them, right? Not really. So the point is, this is a very familiar code for all of us, but I would argue this is one of the most complex code we could write. Because every time we write this loop, we have to stop back and think, did we write this correctly? Did we make a mistake in writing this? In other words, this code has a lot of moving parts. And as we are writing this code, every time we touch this code, we have to make sure we did not break this iteration. This is like walking in the mall, and every few minutes we have to turn and look behind to see if the guy behind us carrying a knife is about to attack us. That's not the way to live. So this is a very rudimentary code. This is called primitive abscission, and we have done this for a very long time. Now, how do we output the value in here? We could say numbers and provide the value of I, the index, and we could ask it to display the results, and you can see it did display the value of the iteration itself. But we can do a lot better than this. Now, what is wrong really with this? I talked about what's really wrong with this iteration, but to summarize, this iteration really has several problems. One, it's got too many moving parts. We have to start with the value of I. We got to initialize it properly. We have to set the boundary condition properly in this case again. We have to make sure we are incrementing the value properly. So there's a lot of things we have to make sure we have got it right. And then look at the noise in this code as well. Not only did we have to set the iteration, but we had to get the value from the collection as well using the get method. And that is very basic operation with a lot of effort that we have to put in. But fortunately, we don't have to do that. Already in most languages, including Java and C#, for example, we could use the for each statement. Now, what does a for each statement really do? Well, let's take a look at an example right away before we talk about it. So we could say, for example, element over here, and which is in the values of numbers, and then we could output, in this case, just the element itself. Now notice how sweet that is compared to the old code we wrote. Now this is where we are using the for each statement. If this was C# code, we'd be using the for each keyword rather than using the for itself. But essentially both of those are external iterators still. But what does this really do? This one is a syntax sugar really for navigating through each of the elements in the collection using the iterator. So in other words, if we take a look at this code at the bytecode level, or in the case of C# at the CLR-IL level, what we will notice in this case is we simply are navigating through the collection by calling the iterators next method and has next method. So essentially we are saying if there are more elements in the collection, keep giving me the next element. So So this also falls in the external iterator category. Now this code definitely is much simpler than the previous version we saw. So if we don't have any reason to use the index operation, in other words, we're not interested in manipulating the collection itself, like adding and removing elements at a position, but only mostly working with the elements in the collection itself, then it's much better to use this kind of loop rather than using the traditional for loop itself. But having said that, the external iterator is not very desirable either. Now, why is that? If you really look at the external iterator we saw so far, in both of these cases, we are controlling the iteration every step of the way. Not only are we telling what we want to do, which is iterate, but we are also spelling out the details as to how to do it as well, which is go to the next element and next element and next element. This is like having a rude dog at home where you have to say go and the dog doesn't move and you have to push it every few steps, and that is the nature of this particular iteration. Now, the symptom of this external iteration is because we control the iteration entirely, we are left with the entire controlling, which means we really cannot benefit from a lot of good practices we have gained in programming. For example, one of the primary reasons we want to program in object-oriented programming languages is we want to make use of polymorphism. Well, fundamentally, this code really is non-polymorphic. Now, why do I say it is non-polymorphic? Well, notice we are writing the for loop ourselves and we are passing to it this object and saying loop through the element in this object. Well, by nature, there is no polymorphism here because we are controlling the looping ourselves and managing the entire flow of operation. As a result, we don't have polymorphic call in this case, and furthermore, this looping is entirely sequential. Now, we are condemned to fall into the sequential looping, and if we want to enjoy some other form of iteration, maybe we want to have a concurrency where we have a large collection of numbers in this large number of values in this collection, and we want to be able to iterate through these values more concurrently using multi-core processors. Well, we cannot do this with this particular loop because fundamentally this loop binds two things together. It tells us what we are going to loop through, and it also tells us how we are going to loop through it. Notice these two are combined together in one case, and as a result, it's very difficult to separate these two out right now, and we are forcing ourselves to follow this combination of things. But internal iterators can remove us from this burden. We can use polymorphism. In other words, rather than controlling the looping, we can tell the collection, hey collection, why don't you do the looping? I will simply tell you what to do for each of the elements in the collection. And that's what internal iterators can provide for us. Let's take a quick look at an example of an internal iterator here in Java. So what I'm going to do here is I'm going to say numbers.forEach. Now take a look at this for a minute. This code is not complete yet, but let's take a look at what we are doing very fundamentally different now. Rather than calling a for loop and sending a collection to it, we are calling a for each method on the loop itself. What this gives us off the bat is polymorphic behavior. We are telling the object, in this case the collection, that we want to do the looping, but we are not telling how to do the looping. That is left to the implementation of the for each method. Now the collection can decide based on a certain context how to actually perform this iteration. Now, it can do this sequentially if it chooses to, or if the condition is favorable and desired, it could do the looping concurrently as well, and it could potentially enjoy a lazy optimization of the looping as well. So it opens the door for so many different possibilities by going from an external iteration to an internal iteration. In this presentation, we're not going to see all those benefits. We are simply highlighting some of those, but in later presentations, we will certainly go into those details and see how beautifully we can enjoy some of those benefits. Now, let's go ahead and get this code to work first of all in Java. Well, I'm using Java 8 here, so Java 8 has some interesting interfaces to support this, and one of those interfaces is called a consumer interface, which is called a functional interface. So I'm going to say function.consumer here. So I brought in the consumer interface. and I'm going to simply say new consumer and bring in the integer, and I'm going to implement the consumer interface. So this is going to be an accept method, which is going to take an integer value on my hand, and then I'm going to simply output the value given to us. So we are trading an external iteration to an internal iteration right here. So notice what we did just here. This one line of code I've highlighted here is the one that indicates what we want to do per element being iterated. Now the iteration, unlike the previous case, is on autopilot, so to say. We simply said iterate on these elements, and it took care of the looping. Now it can decide how to loop. In this particular case, in this particular instance, it is going to do sequential looping just like the other one did, but we can vary these options and navigate through a concurrent navigation if you are interested, iteration, and so on. We can work with it. So here is an example of a for each method that accepts a consumer as an object and performs a navigation very nicely. Now this is an example where we can use an internal iteration rather than using an external iteration, and the benefit we get off the bat are several. The first benefit is, rather than controlling the iteration, we indicated what we want to do instead of saying how to do it. In other words, we lose some of the control, and losing control here is a good thing. And the benefit that we get here is that we let the underlying library decide how to loop, and we simply sit back and relax and say what exactly to do for each of the elements. So that is one benefit. The second benefit is, because this call is now polymorphic, the object can decide how to control this looping and can make judgment based on the condition. It could do sequential looping or concurrent looping, what have you. We're not going to see that right now, but we'll take a look at that later on, but it opens up the possibilities for those. Now, given all of these, we can certainly agree that we have benefits on our hand, but this code is very ceremonious here in Java. Well, thankfully, Java provides lambda expressions, so we don't have to go through all these efforts right here. So quickly, I'll show how this is going to look like in lambda expressions without really explaining how this is being implemented, but that would be a topic of a later presentation where we'll go from here, the ceremonious code, and refactor into a lot better code using lambda expressions. But just for our purpose, right quickly here, let's go ahead and say I want to just print the value, and notice that ceremony is gone, and we can enjoy the internal iteration. This is supported in a lot of different languages. For example, let's take a look at how this is going to look like in a language like Groovy. So I could say, for example, over here, numbers equals, and let's take the same value of numbers we saw on the other side, and then I could simply say over here, numbers that I want to print, so numbers.each, and we could take a value on our hand, and we could simply print the value, and this is internal iteration in Groovy. Or alternately, we can minimize the amount of code again here by using some Groovy conventions, and we could simply say, for example, print line it, and it is a conventional name for a single valued parameter in Groovy, and we can see how that works. Similar to this, we can try in Scala, for example. We could say numbers equals, and then we could start with a list of numbers again here, and then we could navigate and print it using for each method here in Scala, and we could say, given a value, I want to print the value itself. We could write code like this, for example, or alternately what we could do in here is, oh, this is for each with the lowercase e, there we go, and alternately what we could do is we could also use another convention in Scala. We could say numbers.for each, and simply give the print line itself, and it's smart enough to carry over the value and say that I want to take the parameter given to me and pass it on to the print line function. So we looked at what internal iterators are and how beneficial they are, but I haven't quite talked about removing the ceremony, but showed you how the ceremony can be gone. But we will talk about the ceremony issue later on and go from the declarative, imperative to declarative style of programming. But for now, I want to leave these thoughts. External iteration is where we control the looping. Internal iteration is where we give control and let the underlying library decide that. And as a result, we can enjoy polymorphism, and we can enjoy different way of implementing the code and enjoying the optimizations that the underlying library can provide for us much more effectively than we controlling the iteration itself.